Hello and welcome back to Stationeers. I'm Mick, and today we're going to be having a bit of a play with our new atmospherics devices. Well, not so much new, but our updated ones. Keep calling them new because they look new, but they're just updated. So last time I had a look at the air conditioner, that has changed a bit, and I noticed they've already made a couple of changes on that one to make it a little bit more useful. So that one can or will soon be able to put your setting up to 999 degrees, so you can still use it for heating your furnace, although it'll probably still chew up a crap ton of power. But anyway, that's not what we look at today. Today we want to have a look at this doodad here, the filtration system. This is the next one, well, next one on my list anyway. Might not be on your list, but it's the next most popular one that I use. So I just want to have a look at that one, see what it has done, see if we can still set it up the way I like to set it up, but just using 2 pins instead of I think all 6 that I used on the last one. So, but we'll see what we can do and we'll give it a shot. But first up, let's have a look at it and see if it still has all the janky behavior that it had before. So set up our same test rig that we had for the air conditioners, except they're filtration systems now. So that'll be a bit more fun. So first one we have set up, changing the length of the input pipe. Now that was something that would speed it up and did trap a lot of people when trying to make systems there. So once again, set it up, one with a short input pipe, one with a long input pipe. And this is how many moles per game tick it pulls out. If we switch it on, 56.1, switch the other one on, oh dear, 98. So it does still have that weird input length pipe weirdo thing, which makes no sense. But there we go. Now we have this one here with the output pipe, short output pipe, long output pipe, moles that are moved each game tick, 8.3 and missed 8.3. Right, so we say the output pipe makes no difference. Now the length of the waste pipe, once again, everything's the same except for the length of the waste pipe. Moles per tick, John 56.6 and 56.6. Right, so that makes no difference, which is good. The output makes no difference, which is good. The input does make a difference, which is bad. Dear. Okay, so they haven't fixed that one yet, but it's something we know about, something we can work with. Although it will be a trap. I did blow up a lot of pipes trying to build with these things when I first started because I didn't know about that. But anyway, we shall deal with it and we shall see what we can build. Now a few other tricks there, because that is still part of the thing there. I imagine the filter usage is still the same. So we'll set up a bit of test for that and see how we go. Right, so here we have our number 2 experiment. We have, on Lulan here, we have oxygen, nitrogen, carbon dioxide and pollutant here. A tiny bit of pollutant, and we have our 4, don't worry about those 2, we have 4 which are completely 100% identical except for the one that's different. Now these ones are set up just to see how our filter usages work. Now this one has, well, these 3 have the short pipe, this one has a long pipe. We're going to see how the filter usage goes. So we're just going to flick them on, 1, 2, 3 and 4, and we'll leave them sit there for a little while and just see how things go. They're all sucking in, they're all sucking out the pipe. Now there is no nitrous here, so that one is getting nothing in there. The question is, will it still use the filters, or the filters only dependent on the gas that matches the filters, or the filters dependent on when it's running? Now these ones are pollutant. There's a tiny bit of pollutant, and it's all going in there. So do the filters get used by the amount of gas that's done, or just the time? So if that one and that one are both the same, then it's just time. If this one and the oxygen are both the same, then it's definitely time. If that one's less than the oxygen, it goes on the quantity of gas, so we'll find out. So this one has a long pipe, so it should be pumping through more per second So you find that one's got 1 megapascal, that's got 2 megapascals, so it'll go almost double the speed. Will it use double the filter, or will it use the same amount just based on time? So we'll come back and have a look at them. Well, they are going pretty quick. Maybe I won't wait too long before coming back and having a look at them. Okay, but we'll get back to them a bit later. Rightio. Okay, a little bit later. Let's just switch them all off again. Now, in our tanks, we have nothing in the pollutant tank, as well the nitrous tank, because there's nothing there. Our filters are still on 100%. It has not used the filters at all. Well, because it's done nothing, but that was expected, so it's not based just on the operating time itself. In here we have subtle pollutants, because there's not much in the atmosphere. And we have used 7% on our filter. Now the other one, the oxygen one, which runs at the same speed, we've got a lot more oxygen in the atmosphere, and we've picked 12 megapascals of that. That one is 7% used, so it will use the filters based on the actual time running, not the actual amount of gas done. Now this is a faster operating one, so oxygen once again, it has produced 21.5 megapascals versus 25, and the filters are sitting on 7%. So yeah, it will use the filters based on time, and if there's an available gas. If there's no available gas, it will not use the filters. But depending, it doesn't matter how much the gas is there or how much your flow rate is, the filters will all be used based on time. So the longer your input pipe is, the better value you get out of your filters. All right, so that is unchanged from the old machines. Let's have another look at them. Now we have one here. She's running at 110 watts. How are we doing for our, the other one I want. Now you are saying, and this one here, required power is 10 watts. Okay, so that one's a little bit janky on the power logic as well. I imagine that might be something, yeah, the network says it's running off 10 watts, so it's, I'd say the network analyzer is getting its power, its information from this thing here, so that's wrong as well. But our cable analyzer tells us the truth, it's 110 watts running. Or it could be 100 watts and it's just got the 10 watts from everything else. Well, anyway, it's more than 10 watts. But I dare say that one will get fixed pretty quickly. And if you switch it off, well, if you switch it off at 0 watts, who would have thought that? Why did I even try that as an experiment? Okay, so where is our nitrous filters? Does it draw less power if there's nothing there to actually draw? So if we change you, well, yeah, even if there's nothing there, it's still drawing full power because it's operating. So yeah, that makes sense. Now the length of the pipe would change the speed of it. So if we bump up the speed, nope, it still draws 110 watts. No, that's cool. So there you go. The power draw is always the same. Now whatever you draw in, of course, comes in this side. The filtered gas comes out this one here, and everything else comes out this port here. If you have no filters in there, everything will go to waste. So if your filters run out, it won't start blowing everything through here. It'll just put everything to the waste. So if you do have it set up to collect something in one direction, another thing in another direction, make sure you don't run out of filters or it will spoil that for you. Right, but that's your basic operation there. Let's have a go at this thing and see if we can build it into anything with just the two lugs. Now, a while ago, I did write myself a bit of a code to control the old ones there. This is one here. It's my gas harvester version 3. Now this one did have the tank, an alarm, a couple of lights to tell you what those things were up to. and an analyzer or a tank for where you're storing all your gases. I've just currently got it hooked out to the atmosphere now to give it a demo, but that'll do the job for us. So if we activate our code, it switches on. So what it's doing is it's looking to see if there's any oxygen, because it can check and see. It says, oh, I've got oxygen in those ones there. So I can say, well, is there oxygen in here? Yes, switch it on. So if I shut that off, there's now no oxygen in there. It shuts off. If I put it back on, it comes back on again. Now it also keeps an eye on these ones here. It was the filter we used a little bit before, so it is slightly used. If I pull it out, it says the filter is now empty completely and gives us an alarm. Put it back in. The other one goes off. Now if I pull them both out, it has actually shut off the machine. Although you can't really see it because of that one there. It is a red light there. Put one back in. It knows there's one in there. It can operate. If both of them that switch off there, it switches off the machine for you. And they're there. But now if we're going to hook that up into this machine, I've only got 2 items to hook it to. And I have 1, 2, 3, 4, 5 items to hook up to. And well, it doesn't have to hook up to the machine itself. That was a 6 item. So I was using all 6 pins to control that. Now I've only got 2. So how are we going to do that? Well, the good part of it is when they did the logic on this thing here, we should find that we have input and output ones there. So we've got our ratios, inputs, ratios, outputs, temperatures, pressures, inputs and outputs. So we do know the machine itself can read the input from the input pipe. You don't need an analyzer to hook it up. So that's one thing we don't need. It also knows what's over here. So you don't need anything over there, a pin for that one either, because it can read it through the output pipe there. Which means, well, there's still 4 things to hook up. Well, I mean, you don't have to hook up the machine itself. So there's still 3 things to hook up, but we've only got 2 pins. And I kind of would like to be able to put in a temperature controller on it. Because when we were on Vulcan there, we found that it store gas at any old temperature, and you then wanted to be able to switch on a refrigeration system to do that as well. So can we build it with all of this stuff and put a temperature controller on it as well and reduce that all to 2 pins? Sure, why not? Well, I suppose first up we can't have 2 of them. So maybe, well, one of the pins has got to be for a temperature controller. That means I can probably only provide cooling to it, but cooling is usually the thing we've got to provide most of all. So if I can hook a cooler up to 1 pin, and the other pin could be one of these, which has somehow got to show both filters. Yeah. Or maybe I just show the smallest one. Well, let's have a go and see what we can come up with. Okay, so here is what we've got. Now so I've got our tank, got our oxygen. It's just getting its supply from outside. Better switch that on. And the waste is just being dumped back out again there. Our filtered output is coming through to a little cooler, which goes to a heat exchanger. So if we wanted to say if that's too hot, it'll suck some cold gas out of there, because it will does just allow gas to go into the cooler section there, which will be cooled down by the cooler gas. You could put this pump on the cooler side of it. That would work as well. We're just going to suck out gas, which will already be pre-cooled, into this pipe when it gets too hot, and the one-way valve will just allow more gas to go into there to replace the gas we're pulling out. So that'll be the way we control our temperature. So we just got to switch that valve on and off, and we're good to go. Once again, we're going to have to monitor these things. So if they both go bad, we switch it off. we've got to show both of them on the one of them somehow. Still want to have our master alarm. And this we're to control. Now, cool thing on this one is our computer does hook straight up to our filtration device to our IC that is not in there. To my IC, which has been in there all the time, and I didn't forget it at all. Right, so we're good there now. Now, so what have we got onto this thing? We have, and they are. Now we have, I've got output and output 2. So I'm guessing that is the filtration. Which one of them is output 2? I'm guessing the, if I pull off the pipe it might tell me. Unfiltered. And filtered. Well, one of them's output, the other one's output 2. Awesome. Well, we'll figure that one out as we go. Oh, come on. There we go. Now, so input will obviously be the input side of it. Output, I'm guessing, is probably the filtered, and output 2 would be the unfiltered. We'll figure it out as we go. Right, so we can get our ratio of water. You can't have water in there. Ooh. Or is that a sneak peek of something to come? Oh. We're back to gaseous water, are we? Right. Anyway, am I reading too much into that? But anyway, there we go. So we want to know total moles. Yeah, yep, right. So we can read what's the pressure. We can read the pressure in the tank. We won't be able to read the total moles because that will be in a different atmospheric object, because the pipe and the tank will be different atmospheric objects. So I won't be able to read total moles in there, but I will be able to read the pressure, which will be the same in the pipe and the tank. So I'll have to shut off when it gets to a certain pressure. The input side, we can read whether or not there's oxygen available. If there's not, switch it off. If there is, switch it on. So what else have we got here? We have mode on and open. So they are writables. And setting, which is 50. Okay, so your on and off is obviously that one there. That's open. Okay, you can control that through logic. Awesome. But I dare say it'll have slots, which will be those two, and probably the chip. I can actually look that up on the in this thing first, can't I? Filtration. Yes, we have slots for our filters, one slot for the chip. Our mode is idle and active. Okay, so if I switch it off, that'll be interesting. Right, so if I switch it off, the chip might not be able to switch it back on again, because the chip will also be off. We'll test that out. So I may have to switch it into an idle mode instead of switching it off. So I change the mode, not the on-off. Important one. And our logic slots occupied. Class occupant hash, a prefab hash. Damage quantities, probably how much is left on the filter. Or is it damage? We'll find out. Okay, base power usage is 10 watts. So I'm guessing that's the idle and the 110 is the active. Cool. So now I believe this one dB is the machine itself, and we have D0 and D1 are the pins. Right, so I shall need, I wonder if I can still batch write to these things. So I want to be able to control that one and that one specifically. So they're going to be pins. How do I write that one? Now I can write a setting to the housing, I do believe. if I have a setting on that, where do I see that? So if I write to the dB housing, is it on there? I guess we'll find out. Right. So there we go. That is cold. We're good. Right. So we shall want to know the temperature in there. So I can set up some displays for the tank. Don't really need to know the cooler. I'll set up some displays for the pressure and temperature on the tank. Cool. There we go. So now if I switch on my cooler, it should get colder. It does. If I switch on my doodad, it should get more pressure, which it does. Excellent. So they're working. Now, let's give it a go. So you shall want to be the diode, D0, and you shall be the volume pump. So that's the light, indicator light, and the cooler. So alias dB, the cooler. Oh, come on. The filtration is dB, alias the diode to D0, and the alias the cooler to D1. Right. Start the usual way. Now we shall want to look up the filters. If they're both bad, we shut it off. Well, let's see if we can display the filters on the one light. So how the hell are we going to do that? Well, I suppose we could display the lowest one on there. When one's empty, we switch on the light to show that one's empty and display the other one. Does that work? They're both the same. So let's run one of them for a long time, shall we? Right, so I want to display the smallest one of them onto there, so I shall need to read them both. So I shall load into R0 from the filtration load slot, won't I? Load slot into R0 from the filtration slot 0 QANTITY and a load slot into R1 from the filtration slot 1 quantity. Now what do we do with them? So if they're both 0, so if we say either of them are good, or R3 is, or R2 is R0 and R1. So if either of them are good, and let's just say R set equal to 0, invert that, means none of them are good. Save filtration on R2. Oh, come on. There we go. And jump to the start. Firm, export. They're off. Oh, because I've only got one filter in there. No, that's not right. One of them's good. So one's bad, one's good, or either of them, one's good. Oh, we're switching it on. Okay, yeah, right, yep, we're good. I don't need that one. Oh, that's right. We had to say active, didn't we? Mode was mode, not on. So okay, if it does switch itself off, it cannot switch itself back on. So it is mode. Has it stopped? Okay, mode is 0. I can't see any whooshy things coming out of there. And the whooshy things start again. Okay, so I'm guessing that that does shut it down. Oh, of course, switching it off still can't switch itself back on again, can it? Right. Okay. There we go. So if both of them are off, it does switch itself off. I guess I probably want to run a number of conditions for switching it off, don't I? So I'll probably need to have a running total on that one there. So alias filteron. Let's call that for register 10. So that will go right down the bottom for filteron, and we shall say filteron. Right, so that'll be our first condition there. If both filters are bad, or if either filter is good, we can switch the filter on. If they're both bad, filter on is a negative. So we'll just use that different parts of the code as we go along to make sure that we can actually do that. Right, so we've got a filter in there we're okay to switch on. So now we want to look at them and sort of say, we want to display on the diode if there's any of them there. So I shall say, so we've got to find the minimum of them there. Oh, if the minimum one is 0, we're going to switch on the light and display the maximum of them. Nice. Right, so I guess if we say R2 is a minimum of R0 and R1, right, so if that's 0, we need to switch the light on. So set equal to 0. Oh, use R3, what the hell. R3, if R2 is equal to 0, and we say to the diode, if I spell it right, diode on R3. Right, so if the minimum is equal to 0, switch the diode on. Right, now, if it's not equal to 0, we need to display that. We need to display R2 as the setting. Let's get down a bit further. Say to the diode setting, I think it is, R2, which is the minimum of those two. So if R3 is maximum, we might have to do a branch on this one. I'll try and avoid branches, but we might have to. Or if we select. Okay, R2 is a minimum of those two. I've used R3, so I can use it again. So if I say that is the maximum of, so R3 is the maximum of R0 and R1, and I can just say so SELE select, so write to R2 based on R2, because if R2 is equal to 0, or if R2 is true, if R2 is equal to 0, we want to take R3. If R2 is not equal to 0, we'll keep it. Right, so if R2 is greater than 0, we keep R2. If it's equal to 0, we take R3, which is a maximum. That is confusing as hell, but that should do us for us. Right, confirm, export that, switch it on. We have a light on. They're both 0. You're on, you're good. How are you doing? Whoop. 87, that'll do us. The light is on means one of them's empty. You're not showing 87. Why not? So you're the minimum of 0 versus R2. Let's have a look at select. I've chosen the wrong one. Where are you? You're probably in the SEs. Right. Register equals B if A is non-zero. Yeah, I'll see if it is 0. Right. So if the minimum, R2, is equal to 0, it's C, R3. That should work. But it doesn't. Is it setting? Is that what we want to write? Setting's 87. That doesn't look very 87. Oh, do I need a 0.87? Okay. Div. There we go. So that gives a quantity out of 100. This needs a quantity out of 1. Okay, so I pull you out. Light is on, and we have, oh, it's 94. Okay, put them both in. It gives us a less one. Right. Okay, so that's good. So when the light's on, it means a cartridge is empty, and that's what's left of the other one. When they're both in there, that is the smallest one. Cool. Right, so we're displaying both cartridges on the one thing. Well, sort of displaying them both. We're displaying the critical information on there. Can I change the colour of that? I don't really like the colour on that. Doesn't look like it. Awesome. It used to be green and red. Oh well, that'll do. Right. So I can now display both cartridges on there. Now I want a light. Well, that one sort of gives me an alarm, but I want the light in another room. I could put a save value to the setting on this. I don't know if that setting actually does anything. Oh, wait a minute. If I have one light in another room, all I need is to batch read all of these things here across all of my filtration systems. So if any of them come on, those lights are on, switch on the master alarm in another room. Well, that'll work. So I will just need a logic chip I'll need two of them. So I'll need a batch reader. We'll get there, batch reader, you, and a logic writer. Cool. So, cable. Doop, doop, doop. Doop, 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 doop. There we go. Right, so I've just got the output of that one hooked to the input of this one, or actually the other way around. Yep, so batch reader output into the input of that one there. So we are reading the, they are, I call them diodes, diode slides on, we should take the maximum. So if any of them are switched on, we'll get a true on that one there. So the input goes from the batch reader, it's the only one that's connected. Output goes to the flashing light and on. Right, so now if I put one of these out, yep, flashing light comes on, alarm off. Nice, there we go. Okay, so that is our flashing lights all coming off one pin. So now I just need the cooler. So I shall probably define a maximum temperature. Or a minimum temperature. Min temperature. I suppose it depends on whether you've got a heater or a cooler. I think it's usually a cooler is going to be what you want. We shall say our minimum temperature shall be, well, I'll say 0, 273 Kelvin. So once it gets to that, we can shut the cooler off. So we shall want, it was, well, we're going to guess it was output 1. We don't really know. So we shall load into R0 from the filtration. The temperature output was output sure. No. Let's have a look. It's called our temperature output is going to be, isn't it? Temperature output, right. Whoops. It will be temperature output. There we go. We shall say a set greater than. So set R0 if the temperature is greater than minimum temperature. Save to our cooler on R0. Firm export. Our cooler is on. As our temperature drops to 0, that should switch off. And bingo. Nice. Okay, so that's the temperature controlled, the light controlled. If we pull out both of them, it should shut itself off. Yes, thank you, letting us know that. I've still got wishy things going around. It has gone into low power. I might, let's put a little power measurer on there so as we do actually know that it has gone into low power. Okay, so everything's running on 425 watts. So you have 500. Okay. Okay, that's weird. 438 watts. So 390 with that thing switched off. Switch it on. What the hell is going on? Required power is 10 watts. Yeah, something's not right there. But anyway, I don't know. Okay, so right, we have got the lights running. We've got the right writing. We've just got to get this to figure out when we want to switch on. So we need to check in there and see if we have a minimum amount of gas, I guess. So we shall want to define a minimum. I'll probably want to check the tank as well. So we shall put in a max pressure in the tank of say, I'll just put 1 megapascal in there to be able to test it. So we shall want to put in here, they're all good, they're all good, they're all good. Now I could switch it off if the temperature gets too high. That could be another thing we put in there. So we don't want to be pumping a heap of gas in there from our waste tank if the pressure in there, the temperature in there has gone too high. Or we can suck it all in there and then cool it down. Yeah, doesn't really matter, I guess. Right, so we shall say we want to check the tank. Now that's going to be the output 1. Yes, we tested that because it worked with the temperature. So load into R0 from the filtration pressure output. We shall set less than. We can switch it on when it's less than. So when the pressure is less than max pressure, true. Now we can have our filter on. So we'll have to say, and our old filteron is a combination of the old filteron and the result of our pressure test, R0. So if it passes that test where we have both filters, we can switch it on. If it also passes this test here, so both of them have got to be passed, we can switch it on. Confirm, export. Now we are above 1 megapascal, so it should switch off. The power has gone down, it's gone into low power mode. That's good, there's no whooshy things going around, so we are switched off. You're not picking up anything else, good. Alright, so we are up to that. I can switch that up to 2 megapascals and it should come back on again. 2, confirm, export. And away she goes again. Nice. Right, so we're still only 2 pins in. We are controlling the maximum pressure in there. We are controlling our lights, monitoring our filters. Well, we're not really controlling that, but we are sort of with a couple of logic switches there to do that. So now we've just got to check the input to make sure there is something there worth picking up. We can say how am I going to do that? So I shall put I should put an input quantity. Define input amount. We shall say 10. I probably should pick something that I know we've actually got in there first, shouldn't I? Right, so make sure I have got that quantity in the pipe network. I'll switch you off. Right. And what do I end up with in there? So I have oxygen 13 mole. Right. Now I can say, so we know we're looking for oxygen because that's what our filters are. So we load into R0 from the filtration was total moles. No, not that one. That one. It was total moles. Total moles input. So from there, try the capital T, total moles input, shall load into R1 from the filtration ratio oxygen input. So then we shall multiply those two together, R0 and R1. Okay, so that'll give me the number of moles of oxygen there. So we shall set greater than, if we have greater than our input amount. So if the total moles is greater than the input amount, which is 10 moles, we can switch it on. So once again, we want to check with our filteron command. So let's copy you down there, put you down there, because we don't want to switch it on if it doesn't meet the other criteria. So the filters have got to be good, and the pressure output tank has got to be not too high, and there's got to be something there to actually pick up. Right, so if we export that, I've got it switched off. Right, so the pressure's good. Our filters are good. If I switch you off, you should go into low power mode, which you have because there is nothing there to do it. Now, it doesn't actually tell us that it's on. That's kind of annoying. There's nothing on the display screen to tell us what mode it's in. I could probably write that to the DB housing, couldn't I? Mode filteron, so can I do that? Save to filtration, setting filteron. I still have no way of reading that setting. Right. Setting is 0. How do I know it's setting 0? I don't know. Okay, so it might be nice if the status screen actually told us that, but it doesn't. So I don't know if that's actually on. I can't switch that off, or it'll never switch back on again. Crap. How do I know that it's actually running? I don't. Damn, why do you only have 2 pins? Crap. Well, it does everything it needs to do. It's not the most user-friendly thing, though. It doesn't tell you much what it's doing. It just kind of sits there looking dumb, but quietly doing what it's meant to be doing. Oh well. So that is quite useful. So that will do what we want. So if I have a heap of them, they'll switch on that light. I can read all of them. If any of them are on, I can switch on the alarm in the control room. It'll tell me to come out here and look at it, and I just have to find the one that has the light on and switch out that one there. I think that works. Oh, cool. And you're on again. Nice. Okay, I can live with that. So let's maybe set up a bigger system and see how it all goes. Now, there's two main ways you can hook up your atmospheric systems there. First one is your serial connection, where it comes from the rest of your base. Don't worry about them. It comes from the rest of the base. Pipe comes all the way around, comes into the first one, filters out one of the gases, passes out of the waste, into the next one, filters out the next gas, into the next one, filters out the next gas, and anything that doesn't go into any of those ones, it's just crap that you don't want, just think it's blown out, gone. Not a problem. So you're only capturing what you get. It goes through each filter once, and the rest of it just goes away. Now there's pros and cons in this one here, in that this one, well, it only processes each bit of gas once, so it's going to be the nicest on your filters. The downside of it is the length of the input pipe does matter. So these ones only have 1, 2, 3, 4, 5, 6 lengths of pipe in there, so their maximum speed is going to be capped by that. So they won't be as fast. The other trick is that the length of this input pipe is very long. So this one is going to run a lot faster than that one, so it will probably build up pressure in here until this pipe explodes, which is something I did a lot of in my early days of Stationeers. That pipe was always exploding and I never knew why. It's because of that. This machine will run faster because of that long pipe. So the trick there is 1, 2, 3, 4, 5, 6 lengths of pipe. I've got to count 1, 2, 3, 4, 5, 6 lengths of pipe, and then just cut the pipe. So I cannot have any more than that. So now that that one has 6 lengths of pipe coming into it, it won't blow everything up. But I need to have the pipe going still, so I can just put in a valve. I can just put in either a one-way valve like that or a regular valve and just leave it open. Doesn't matter. All it has to do is break that pipe so it believes it only has 6 lengths of pipe in it, the same as these ones here. Once again, you are then limited by that. So yeah, I say pros and cons. It's easy to set up. What's more, you can program this all with a single chip, because you're going to switch them, either them all on at once or all off at the same time. So you just need to monitor this. You just have a single chip with a batch write on it, which just says, yeah, switch them all on or switch them all off. Doesn't really matter. But as we picked up this one, the program to look for something there, we're going to use the second method for setting it up, which is to just put in a parallel system. So let's just forget about that one there. So the pipe comes from the rest of the base or a storage tank or whatever you've got there, and each filter will take out whatever it wants to the tank, and everything else gets returned to this pipe here for someone else to use. The advantage is I can just, if only one of these has gas that it wants, I can switch on just one of them. If they all want gas out of it, I can switch them all on. Because this is a massively long pipe, all of these will run very, very quickly. So if there's a lot of gas in there, these things will suck it all up as quick as you like. So that is very handy. The downside of it is I have 3 filters here, and I think there's 6 different gases. So anything that these ones don't pick up stays in the pipe. So if there's any pollutants or anything else that I don't want to get in there, they stay in there unless I hook up another filtration to purge them out of the system. So I say pros and cons. These ones will be faster than these ones. These ones, the control circuitry is going to be more complex than these ones. These ones you have to purge the pipe. These ones you don't. So whether you want speed or simplicity, that's about what you're looking at here. This is the simple one, easy to do, all or nothing. This one here takes a little bit more stuffing around, but this one is the one I usually go for. So he's all good. But that's what we're going to do. So I'll set up one of these. You can put the same code in each one. I guess I'll need to modify it for each different gas. But other than that, I can put in the cooler circuit, and we shall just, I guess we'll just pick out whatever's in the atmosphere here. We have carbon dioxide, nitrogen, and pollutant. I'll pick out the three useful ones, the CO2, the nitrogen, the oxygen. Cool, so I'll set up the chips and power it all up, hook up the air conditioner, and we should be good to go. Cool. Okay, I just had a really stupid idea. How about if I use this thing to say when it's on or off? I can write to that value. So if I say filtration open, right, confirm, export, switch you on. Oh, so you're switching on and off. If I switch that, you stay off. Maybe I should reverse that so it opens when it's so it closes when it's switched on, so you can't accidentally remove the chip. Safety first. So set equal to 0. Set R0 if filteron equals 0 and R0. So open R0. So if that's equal to 0, switch to 1, right, confirm. Right, so that's switched off. I can remove the chip. Switch it on. What's happening is it keeps sucking the pipe dry, so I really should put an active vent on there or something. Okay, I now have a way of knowing whether or not it's switched on. It's pretty silly, but what the hell? It works. It ain't stupid if it works, as the saying goes. Right, so if I put you into there, borrow you for there, you'll switch on, you'll read from there, you can go to CO2, so I'll need some more chips. You. So if I put you to ratio nitrogen, nitrogen, confirm, export, you can go to my nitrogen filter and you can go to ratio, come on, carbon dioxide. I might change the code to actually automatically detect the filters. It might make it a bit easier, but not right now. Oop. Right, now we switch you on. I should have pressure in you, 2 megapascals, plenty of that. Now I should just be able to switch you on, and we're away. Switch you on. See, now that one can operate and not affect any of the other ones. If I pull out your filters, you come on. You come on. If I pull out you and you switch off. Nice. And yeah, that vent's a bit savage down there, isn't it? Put them back in, away you go again. So I switch you on, we're away. Switch you on, you're away. Once again, you've got the used filters in there. That's the good one. Pull out the bad one. Light comes on and shows me what the other one's got. Excellent. So that's all operating. So now I've just got to switch to set up this light, don't I? Rightio, we can do that easy enough. So I just need, so I see, try logic. There we go. So I need the batch reader. That's you. And the logic writer. You are good. And some cables. Once again, just connect the output of that one to the input of that one. And we've got to hook up all the rest of them. And we're back into the... That's very annoying. Right, so now we need the input is from the diode slides. We are reading the maximum. We are reading the on. We got one? That's the filtration diode. There we go. 0. You've really taken all the oxygen, have you? Okay. So you are reading the input from the batch reader. We are outputting to the flashing light and on. Right, so yoink you out. We're not getting the flashing light. Why? That light went on. We are reading the maximum from the diode slides. Maximum, we're not reading anything. Right, we're reading the on, you fool. There we go. I'll put you back. That switches off. Excellent. So that should work with any of these ones there. And you. Nice. Now why have you switched off? That would be the big question. There's plenty of oxygen in there. Oh, we got to 2 megapascals. That was our shut-off. Okay, so we've already got there. And really the CO2... Oh, I don't have much CO2 in there. Right, okay. And the nitrogen is on its way too. Okay, so the oxygen, atmosphere is mostly oxygen, so it did fill up first. Right, so that's filled up the tank. It is shut off. That one is well on its way. Nitrogen should be getting there pretty soon. So I'd better bump up that max pressure, or it's going to be a pretty useless one. Getting there. So it takes a little while for the difference between the pipe and the tank to equalise by the look of it. And the CO2 is going to take a while to get there. No, that's cool. Right. That is working. Once again, all the pollutant will stay in there until I hook up another filter to actually purge that out. I don't want to get that to a tank, so I can just purge that straight out to the atmosphere. So that is cool. You have stopped. And the CO2 is still going. That is cool. So those ones, once again, those ones operate very quickly due to the long input pipe, but these ones will still do the job the same way. You don't need the same control circuitry on them because they are an all on or all off. As I say, but this one is one of the fastest ways of doing it. Cool. Well, there you go. That's that is the new filtration stuff. The 2 pins I have criticised, said that's not going to be enough. We have managed to make 2. So stop your sooking, just change the way you do things. I think that still works pretty good. We could, what else would you want to hook it to? That thing opening and closing is still pretty silly, but anyway, that is what it is. As I say, it'd be nice if the status screen would change colour or tell us something there, but it doesn't, so get over it. Right, filtration system. So we've got a new bit of code there that'll run them quite nicely. Operates with the 2 pins, works with that one. So I could change that up to automatically detect the cartridges in there so as it knows what gas to look for automatically. I might do that before I put it up. I'll paste it onto the video. Yeah, there we go. Is all working. The filtration unit hasn't changed much other than they've stuffed an IC socket into it. That's about all. The overall operation remains the same as it was before. So they didn't fix the janky behaviour. I don't think it's going to be a real issue with these ones there, because it can be quite an advantage to have that extra speed for your filtration systems. But anyway, that's cool. So, new filtration system working nicely. So, all good. Till next time, happy building. See ya.